You think astronauts are heroes who float in zero gravity and come home to ticker tape parades. Today, you are going to see the absolute worst ways humans have died reaching for the stars. Some were freak accidents, some were completely inexcusably preventable. By the end of this video, you will never watch a rocket launch the same way again. It is June of 1971. You are looking at the crew of Soyuz 11. These three men just set a massive record. They spent 22 days living on the world's first space station. They proved humans could survive in space for weeks. Their mission was a total success. So what went wrong? As they descended back to Earth, they detached the parts of their ship they no longer needed. When those explosive bolts fired, a tiny piece of debris hit a pressure valve. This valve was only supposed to open right before they hit the ground to let fresh air in. Instead, it popped open while they were still 104 miles above the Earth. Imagine you are in that tiny metal ball. Suddenly, the air starts rushing out into the absolute vacuum of space. You don't have a spacesuit on. Because the capsule is so small, you only have about 15 seconds of useful consciousness before your brain shuts down. The entire cabin loses all its oxygen in just 112 seconds. The men scrambled to find the leak, but it was hidden beneath their seats. They suffocated in the cold, dark vacuum. To this day, the crew of Soyuz 11 are the only human beings to actually die in outer space, above the Kármán line. Because of them, every astronaut now wears a pressurized suit during launch and landing. But what if you knew you were going to die before you even got in the rocket? It is 1967. You are Vladimir Komarov, a Soviet cosmonaut. You are assigned to fly a brand new ship called Soyuz 1. The problem? You and your engineers have found over 200 fatal flaws in this spacecraft. The parachute is broken, the steering is broken, the heat shield is weak. You know this ship is a death trap, so why do you get in? Because of politics. The government wants a massive space victory for a national holiday. They refuse to delay the launch, and you have a terrible choice to make. If you refuse to fly, the government will put your backup pilot in the seat instead. Your backup is your best friend, Yuri Gagarin, the first man in space. You know that if you step down, your best friend will die. So you step up. You walk to the launch pad knowing you are never coming back. The moment you reach orbit, the nightmare begins. Your solar panels fail to open. You lose half your power. You cannot steer the ship. You are tumbling wildly through the blackness of space. For 18 brutal orbits, you fight to stabilize the ship manually. Against all odds, you manage to point the capsule back at Earth and fire the engines to go home. You hit the atmosphere. The extreme heat blasts the outside of your ship, but you survive the flames. You are falling at over 250 miles per hour. You hit the button to deploy your main parachute. Nothing happens. The container is jammed. You deploy the backup parachute. It gets tangled in the first one. You have zero drag. You are in free fall. American listening posts on the ground pick up your final radio transmission. You are screaming, cursing the officials who forced you into this broken machine. You hit the ground with the force of a meteor. Your spacecraft is flattened into a disc just 3 feet high. You sacrificed yourself so your friend could live. Sometimes the terror does not happen instantly. Sometimes you are a dead man walking and you don't even know it. Fast forward to January 2003. You are one of the 7 astronauts strapping into the Space Shuttle Columbia. You blast off into a beautiful blue sky. Everything feels perfect. But 81 seconds after liftoff, something terrifying happens. A piece of hard foam, about the size of a briefcase, breaks off the giant orange fuel tank. It smashes into the left wing of your shuttle at over 500 miles per hour. Here's the tragedy. Down on Earth, the engineers see this on the cameras. They know it looks bad. They beg their bosses to ask the military for satellite photos of your wing to check for damage, but the management says no. They say foam strikes happen all the time. They say even if the wing is broken, there's nothing you can do about it in space anyway. They refuse to look. So for 16 days, you float in orbit. You run science experiments. You laugh with your crew. You talk to your family on the radio. You have no idea that there's a massive 10-inch hole ripped straight through the protective armor of your left wing. You are perfectly safe in the vacuum of space, but the moment you try to come home, that hole will be your doom. It's time to land. You enter the atmosphere at 17,000 miles per hour. The friction of the air turns the outside of your ship into a fiery plasma, hitting temperatures of 2,500 degrees. The armor is supposed to bounce this fire away, but because of the hole, that superheated plasma flows directly inside your left wing. It melts the aluminum frame from the inside out. Your ship's computers frantically try to adjust, fighting the drag, but it is too late. The wing rips completely off. Traveling at over 200,000 feet in the air, the shuttle violently tears itself apart. You never even knew what went wrong. Sometimes management doesn't just ignore a problem. Sometimes they actively argue against the engineers who are trying to save your life. It's January 1986. You are sitting in the Space Shuttle Challenger. There are 7 of you, including a high school teacher. Millions of kids are watching you on live TV. It's freezing cold outside. It's 18 degrees Fahrenheit. That's incredibly dangerous. The night before, the engineers who built the solid rocket boosters were begging NASA to stop the launch. They warned that the rubber O-rings, the massive seals that keep the rocket fuel from leaking out, would freeze and become too stiff to work. They knew the seals would fail, but NASA was tired of delays. They overruled their own experts and gave the green light. You launch. For the first minute, everything feels incredible. The force pushes you deep into your seat. But on the right side of your ship, the frozen rubber seal fails exactly like the engineers predicted. A jet of 5,000-degree fire shoots out the side of the booster. It acts like a massive blowtorch, cutting directly into the giant fuel tank attached to your ship. At 73 seconds, the tank ruptures. Thousands of gallons of liquid hydrogen and oxygen mix and violently detonate. The explosion fills the sky. The world gasps. But here's the most horrifying part that NASA didn't admit for a long time. You did not die in the explosion. The crew cabin is built like a titanium bank vault. The explosion simply rips your cabin away from the rest of your ship. It shoots you 3 miles up into the air, and then you begin to fall. Your emergency oxygen kicks on. You and your crew are likely awake, aware, and trapped. You fall for 2 minutes and 45 seconds in absolute terror before hitting the Earth's surface at 200 miles per hour. It's a completely preventable tragedy driven by impatience. Space travel isn't just rockets going straight up. Sometimes the danger comes when you try to fly an airplane into the absolute edge of the atmosphere. Meet Michael J. Adams. It's 1967, and you are flying the X-115. This is an experimental rocket plane dropped out of the wing of a massive bomber. You ignite the engine, you hit 3,800 miles per hour. You fly so high, over 50 miles up, that the sky turns black, and you officially enter outer space. You did it. But the air is so incredibly thin up here that your normal airplane wings and flaps do absolutely nothing. You have to use tiny thrusters to point your nose. Something goes wrong in your computer system. The plane starts to drift sideways. You don't realize it immediately because there's no wind to push against you. But soon, you are in a massive spinning tumble. You start falling back down toward Earth. As you drop, the air gets thicker. Normally, this is good. The wings should catch the air and let you fly. But you're falling perfectly sideways at Mach 3.5. You hit the thick air like a brick hitting a concrete wall. The aerodynamic pressure is immense. You are slammed with 15 times the force of gravity. The blood drains from your brain and you black out. The G-forces are so incredibly violent that the metal frame of your rocket plane simply snaps in half. You are shredded in the sky, becoming the first person to earn your astronaut wings by dying in space. We look at the stars and dream of exploring them, but space does not care about our dreams. It's an unforgiving environment where a frozen rubber ring, a tiny piece of foam, or a damaged valve means the difference between making history and a horrifying death. These astronauts knew the risks. They stepped into the void anyway, pushing the boundaries of what humans can achieve. Next time you see a rocket launch, don't just look at the fire and the smoke. Think about the people inside, trusting their lives to thousands of parts built by the lowest bidder.